Hey, good evening, everyone, and I'd like to warmly welcome you to today's stream on application security for Node.js. So, today here with us we have Mr. Lirantal, the Director of Developer Advocacy at SNCC, and he's here to share with us his insights on how we can improve the security of our Node.js applications. So, if I'm to tell you a little bit about him, he's a seasoned speaker on topics like this, like on JavaScript and on the mean stack and on the Node.js framework. And he's also a top contributor on open source frameworks like mean.js and mean.io. And on top of that, he was also recognized as a GitHub star last year. So without further ado, let me quickly hand over the stream to Mr. Liran. And hi, Mr. Liran, the stream is yours.
Hey, Akalanka, how's it going? How's everyone doing? Thank you for the intro. Haven't done mean.js and mean.io for a while, but it's awesome that you bring that up. It's part of the stuff that got me into a lot of the modern back then of JavaScript stuff and Node.js. This is 2014, I think. Really way before, but it was cool. So yeah, I'm happy to be here. I think like we prepared some stuff if we want to go to like a demo or just like talk about what does Node.js security looks like. What does it mean today? What's web security about? What's open source security about? So I'm doing that as part of my job at SNCC, basically as a developer advocate for SNCC is a cybersecurity company. So doing like developer first kind of tooling, so very developer based, not really edge or equipment based in that sense. But yeah, I'm like happy to be here and just chat. So like meet everyone, have some answers and discussions going on. Thank you for having me as well. So anything on the chat that we want to like, I'm wondering if we want to figure out maybe if there's any kind of questions. So this would be a good idea to just get people maybe if they have anything they want to learn or ask about web security related topics. Supply chain security is an interesting topic that has been going on recently. I guess you probably have seen it in several occasions, like maybe from like I don't know, like maybe an NPM related incident, security incidents. We've had recently things like COA and user agent and stuff like that. But probably one of the most severe and significant one that I always get back to because it has been one of the most, I think, dangerous attacks that we've seen on the ecosystem and learned about it only 3 months after it happened is the event stream one, which had happened very much in the open as an open source security story. This is an interesting one to look into. And I think we've also like learned a lot from this. So yeah, let me see if I can watch where the stream is going. So if there's any discussions, we can chat about them together. Let's see. So let's see if we can see anything there. Okay. So what do you all want to learn about Node.js and security topics? I think so. Akalanka, if you want to kind of get some discussions going on the stream, that would be great. If you want to join me here,
Yeah,
we can
sure.
just figure out. Okay, cool.
Yeah. So I'm like really interested. No, it's not about security, but before web security, could you like give a small intro about mean.io because I really haven't heard about it before.
Oh, really? Okay, cool. So mean.io is basically from the term that was coined mean, which is Mongolar Express. Did I say Mongolar? MongoDB Express, Angular, and Node.js, but Mongolar is an interesting concept. So that kind of stack of technologies was kind of like the de facto JavaScript all-in-one development language or technologies that was just enabling people to be really full stack, because we're basically doing JavaScript on the back end, front end, even on the server side, like the database side of things. You could like write queries in JavaScript if you wanted to. Not a good idea, but if you wanted, you could do it. So they started as a project from an Israeli company, actually, and called Linovate. And so actually Valery Karpov was the person who coined the term min as a stack, and then a bunch of people, basically the Linovate company that was back in 2014, kind of doing a lot of this, getting into Node really heavily, started a framework and a website, and they called it min.io. And this is basically the beginning of the framework. And min.js is essentially, as it happens with open source, people have different opinions and want to make different decisions. And so min.js is actually the fork out of min.io. So I've been involved with both of them, but I did end up going with min.js as a fork. Amos Haviv was the person who was like the lead developer both on min.io and then forking into min.js, has been doing an amazing things. And that is actually just joining this project as we were. So back then I was a developer at HP Software, the different company than Snake. This was 2014. We were looking at consolidating and doing some migration of the team had been building a marketplace for HP Software content, and it was based on Java, PHP, and Python. If I kind of look at all the components, and we wanted to there was a lot of just different skill set and experiences needed across the team. So we wanted to consolidate, and we were making a decisions to actually migrate a lot of the code and what we've developed into. Essentially into Node.js/Angular, so the JavaScript side of things, and the Java backend for the APIs. So this is how I got involved, and it was very much by just opening issues, learning, fixing small bugs, and up to the point where I was like maintaining releases for min.js, which was amazing.
That's like a kind of like a interesting experience, I guess. So coming back to security, like I'm not really familiar with where to start with security for Node.js. Like, could you maybe start with a quick intro from where we can begin?
Yeah, definitely. So, I mean, the thing I guess that is most common and people are think about it all the time is dependencies, right? Because there's our code, but that probably requires some skill set, some experiences in terms of how do you write, what is secure code, how do you write secure code. But I guess essentially people are thinking about security in terms of their dependencies just because it's like all over the place. We use dependencies kind of like all the time. We start those projects. When we scaffold a new project, a lot of it is just based on open source dependencies. When doing npm install, we see the npm yelling at us, a lot of issues. We need to fix them, a lot of vulnerabilities. So I guess that's kind of like the easiest way to like just get started. And I think for me, if I was like when developer who's involved in getting into security a little bit more, I would then start to like dive deeper and explore what's hiding there. Like if there's a vulnerability that says like if npm, like you're using npm to install packages and it reported on like a package being vulnerable to regular expression denial of service or cross-site scripting kind of issues, then I would kind of like, instead of just fixing it by upgrading, I mean, you should probably, but I would also like dive deeper into like, well, what happens? How can it happen? How can it impact my application? And all of those kind of things. So if you want that, we can do like a quick demo of like what a vulnerability looks like, and we can hack it together and kind of like, take it from there. So maybe that will be like more practical for people.
Yeah, sure. So
cool.
Yeah, great. So let me add your screen to the stream.
Cool, let's do that. Okay, awesome. I can see it. All right, so essentially what I did here is I've got a bunch of projects here. What we want really is this Goof project, which I use a lot for the demos. So I've essentially just imported a project into Snake. This is as simple as just going into app.snake.io, like authenticating with GitHub. Add project, GitHub. You will see a bunch of my repositories and organizations I'm on. And I've essentially just found one of the projects I want to import, imported it, click add selected repositories, and it will scan it. I want to do it now because it will take some time, but we've got it already imported. So once you do import it, you get things like, well, it depends what you want to scan. So by default, what we do is we scan a bunch of manifests and files that we understand, and we'll give you like one holistic picture of the project of what we've found as vulnerabilities. So code analysis is anything from, this is coined as like static application security testing, SAST. It is basically like an ESLint running on the project, but a little bit more, smarter than just ESLint, and it gives you a lot of things like, for example, command injection, which I have part of my code base is I actually have that in the code base, and I'll show you this in a second. And it can show you different things like I'm containerizing my application. So Docker has other vulnerabilities, package JSON, and so on and so on. So what is this project actually? Let's see. So this is the app that I have, right? This is the Goof application. I have like app.js. This is the code base. Maybe I'll make it just a bit smaller so we can get a larger glimpse into everything. And I can do anything from, I guess, sneak test to npm audit or whatever, and you'll see a bunch of vulnerabilities, right? So it's scoring the database. Sneak, you just use npm install -jsnake, and it has it installed globally, and it gives you all of this output, right? So on the command line, of course, this is a vulnerable project as an example, so it has a bunch of them, like a lot. So it could be looking as overwhelming. I totally get, but like, don't worry. It gives you also the idea of like how to fix it. So you could upgrade, this package from 0.47 to 0.52, and then you fix these two vulnerabilities. To kind of help you how to do it, how to upgrade. You can see there's a lot of them, right? There are definitely a lot of vulnerabilities here, including even a license issue that I should probably be aware of. But if I go back into my package JSON here that we opened before, all of those vulnerabilities, let's look at them for a second. You can see that they're all over here, right? Like these are all of the findings, 83 issues that I should probably fix in my project. So one of them is, for example, I'm using a package called marked. So I like showing this demo because it's a nice, fun way of just showing how JavaScript happens as a cross-site scripting vulnerability based on dependencies that we have. So I have marked as a dependency in the project, and it has some vulnerabilities in it, more than one that I should probably fix. If I wanted to fix it with Snyk, that would be pretty easy because first of all, it tells me like which version fixed it and what I should do to fix it. Gives me a lot of information on what's this vulnerability about. I can even go like open one of these links that takes me into kind of like a vulnerability database that shows me a lot more information, how it is, how can I reproduce it, references to like GitHub and stuff like that. But essentially what I really want is to fix it, right? So like I'll do fix this vulnerability. Apparently this one has a proof of concept. It means there's an exploit that someone can use against me in like an automated way. And if I choose that, I can choose all of them, right? I just chose one vulnerability. I can choose more than one. Basically all of them, there's like a button for all of them at the beginning, or just this one. And you could see that it chose that one. Once I click open a fix PR, right, this will open a pull request in my repositories. And basically the change will be updating the log file. We can do that in the meanwhile. So this will be updating the log file and the package JSON. But what is going on with this one? So let's run the app and see. Here. And wait, did I get? I think I don't have my MongoDB running. So let's do that first. Docker Mongo. Just give it a second. Any questions so far?
Nothing from my end. How about the audience?
Okay. So it's okay. Mongo seems to have started. Let me go back. npm start, and we're on. Okay, so now I'll go back to. Okay, a bit slow here, but it's running. Now I have my application. So this is a to-do application. I can enter everything here, right? I can say, don't forget the stream with Lanka. And I can do add Akalanka's picture. Actually, I don't remember if that thing works, so I'll remove that. But this works, and that's like, going to example.com. But the thing is, I actually have, there's actually a vulnerability here, right? Like JavaScript alert 1. And if you do that, so if you have like, if this was regular HTML and you have something like this, right? This is where you don't want, some link, and then you close the href, the anchor HTML element. So this is where you don't want user input to get added to the href value, right? Because they can do JavaScript alert or JavaScript steal your cookies or something else, and that's where things go bad. So essentially, the equivalent of that in Markdown, because we can see that this supports now Markdown, is this. Except if we try to do this, we see that it's breaking up, as in it's not, remove this. It's not really, the XSSR is not really working. But Sneak does tell us, if we go back over here, there's like a regular expression, there is cross-site scripting, there are even like different kinds of cross-site scripting vulnerabilities that affect my version of marked here. And I am using marked, right? Like if I go into package.json and I'll search for marked, this has like the Sneak plugin here to this code. So it gives me all of this nice information already here. Like I know I already have like 11 vulnerabilities here. So obviously this is like a demo application. But I'm using marked here, and I'm using sanitized true. So it looks like maybe those vulnerabilities don't impact me, but let's see if they do. So if I will change some of the content here, like for example, removing the semicolon here to represent it in something called an HTML entity. So I do something like this. And then I remove this ending bracket, the circular one, with something like GS, which is the representation as an HTML entity of that closing bracket. And this is the entity, the representation of a colon. Then, well, it doesn't work yet, but the exploit actually expects it to have any valid JavaScript keyword, like literally the word this or document. So if I add it in, now I get a link, okay, out of this. If I click on it, I get an alert box. So essentially, now think about what is going on here. You're using JavaScript and a bunch of dependencies. Marked is one of them. You maybe tried like to do quality testing and QA kind of things, and or unit test or whatever, and you try to like reproduce it, and you figured out, hey, it doesn't work. But if that input is someone's like fitting it into your application, or it's you're getting this from the database or something, and someone is able to just add as user input whatever they want as links, which makes sense because we can add like Markdown to like readmes and stuff like that. And at the moment you've done this and you are vulnerable to marked, then your application, by kind of like in transition to it, is also getting to be vulnerable, right? So this is kind of one of the things that we should be like really, really aware of. And I'll go back here. So like the fact that I have a lot of dependencies with vulnerabilities is something I should be kind of like more conscious to. I don't know. Do we have any questions on that, or do you want me to like show you a bit of like a bit more on this?
Actually, I do have one. Like, if you like, so this is something like a post request, right? So when you click on the submit button, the data will be transmitted to the other end, right? So how is it like the JavaScript code executed? Like if you just pass it as a text, you'll be directly inserting it to a DB, right? You won't be executing the code, will you?
You mean here?
Yeah. Like
Okay.
how is it an executable code?
Got it. So essentially, when I click enter here, this gets into a database, you write, and then the database brings back the value. So the value of this is essentially just the markdown syntax that gets not transpiled, but converted by marked. So what you see here is already HTML. So why do you see HTML if I added markdown input here, right? So the value itself is indeed markdown, but what turns it into HTML is this following code. If I go into So first off, let me show you a bit before. So I'm using marked. And what mark does is it takes input as which input is a markdown and turns it into HTML. That's what it does. And I'm making it available through this app.locals as a marked function in my view. So if I go back to like my index or my index view, you could see this is basically reading from a layout. So it's extending it. It has a page title, all of those things. And then it loops through all of those to-dos that it got from the database, from MongoDB in this case. And it has an ability, of course, to edit or destroy something, right? This is the ability to edit. If I just like, I think double click on it or something, I think it should be able to edit it or remove it completely. So the content of those things is essentially, if I just give that input, the to do content is the markdown syntax is this, right? So that becomes the value of to do content. And then I'm passing all of that into marked. And what marked does is translate this markdown syntax into HTML. So the HTML version of that, as we've seen, is the following. Let me make that bigger, maybe.
Yeah, got it.
Right? And so it's simply turning it into HTML. Now, you've seen before when I tried like different things, like that, if I didn't have like any protections on marked, this would have also worked, right? Or I could do something, much simpler, like, script, alert, right? The same stuff. But what marked does is it turns those into HTML encoded strings. So this doesn't become a real DOM element. It is actually just like all of these dangerous characters are output encoded in a correct way using HTML entities. And so this doesn't really become a true element that is getting evaluated real time. But this does, right? All of those, where was that content? This. There we go. So this one actually has JavaScript, document, semicolon. So all of this is a valid JavaScript statement, and then it says alert 1. So when you click on it, it just executes. This is the dangerous things that happen with, the concept of essentially, dependencies having vulnerabilities. And even though it might not look like it at first, or you might be enabling, like I did, like sanitization and stuff like that. You see sanitized true, even initialized it to be a secure way, but it doesn't. So what you really kind of like want to do is be able to like fix, remediate all of those things. In the meantime, when we were talking, I think like a fix pull request was opened, you see, to my fork of the repository. By the way, the Goof app is completely open source. You can go to like the Sneak Labs GitHub repository and just like fork it and experiment on your own and learn about all of those things. And like you could see that the files changed within this diff is essentially the minimal sample range possible to like upgrade to like a fixed version of those specific vulnerabilities. And of course, relocking the package lock so that you have that in place. But that's it. And like you could learn more if you just like, you could look at fixes, which give you more of like a very specific view into like what you need to run to fix things. Like it's more summarized. But also you could look at your dependencies, which is pretty cool. Like you could see a list of these are all of the dependencies in my Goof project. So instead of viewing it in a very like one-dimensional view, like this, let me remove some of these windows, like, just my dependencies. And by the way, there's like dev dependencies. I could actually view it over here, which is a list that I can filter based on specific things. I can see which of them has issues, but also I can view it as a tree, which even makes a lot more sense. And it tells me where are the issues coming from. Is something coming from like an internal dependency that I am dependent on, and that introduces the vulnerability. There's like a lot more. So I guess we're kind of concluding kind of at time here. But what I wanted to like leave a lot of you folks with is we're right now running this campaign thing called The Big Fix. which is an amazing opportunity for anyone to just learn a bit about security on anything that you like, whether that's like code security or dependencies or Kubernetes or like containers or something else. The idea is we're running this month-long campaign of just rewarding everyone that does well for security. So if you go ahead, register, like click on this button here, is just basically need to fill in your first name and email. That email address is the one that you signed up for Snyk, or the one that you will sign up if you don't have an account yet. So once you do that, you can like get into like the into the event. And anytime you scan projects and fix them, you just have to fix one vulnerability. You'll get into a free swag of like a Snyk t-shirt, which is pretty cool. But like we want to reward people of like taking care of their projects on open source. So feel free to like just experiment, learn. This is like a good learning activity of just learning about open source vulnerabilities, fixing maybe one of them, which is as easy as I was doing here. You just like basically import a project, click the fix, create a pull request here, merge it, and we'll probably record it in the systems that if I go back here, that it has less vulnerabilities in it. And at that point, you're like, that's it. What you have to do, no raffle or anything else. Like you're getting the the free swag, the t-shirt, and a really good, I think, sense of like doing something, learning something new, and doing something good for everyone else as well.
Yeah. So when I feel like having a tour of this after seeing this session, I'm really feeling like. So I guess we have a little bit of questions in the chat. Would it be possible to like maybe answer one or two of them?
Yeah, we have time.
Great.
Yeah.
So how about this one?
Hi everyone, what are ways to make sure that a Node.js API is secure enough for it to be ready for production? Okay, there are like a lot of things that you should probably do. There's not one. There's never a silver bullet with security. But thank you, Nundan Bandra, because this is like a really good question. I would say at first, like there are facets of security. So for example, let me give you, let's keep this question, in focus, and I'll show you kind of like what I was doing here. So I do have an API here, like this Goof app. It does a bunch of things. If I go back to the application, it has some routes, right? And some of them, if I go into routes index, and it has API endpoint for like login. It has API endpoints for whatever. I don't remember what this does. But it has different things like, redirecting and login success and saving account details and a bunch of stuff. And you see like there's something bad going on, because like you could see how the curly braces showing that potentially like the linter found something. This linter is essentially kind of like the Snyk secure code, the code security kind of like scanning. And if we go back to the UI, we can see it from the ID, but like the UI is like a bit nicer here to show. If you just click on code analysis here, it shows you that you have command injection. So I can click on full details and actually get a view of that routes index that I just showed you. It has like exports create, right? And it told me how the data flows in terms of like it's actually coming from the request from the user, and it flows into all of those areas, now potentially executing a command that is concatenated in an insecure way with user input, which is the URL. So someone can actually run inject commands on my Node.js server. Now there are a bunch of these, right? Like hard-coded secrets and SQL injection, which I have there in the code base. I can see all of those stuff here as well. So if I look for that, exec, you see exports that create, that's the exact same thing we've seen there, but a different view here. So kind of like what I'm trying to say here is to make that API secure, you kind of like need to think about everything, right? Like the holistic way is you want to make sure that you're scanning all of those, insecure code issues that you have. You want to make sure you're actually, it's like best practices, you're following best practices of like how to do how to build APIs correctly. For example, it's not just even security. Like maybe you want to make want to have high availability, so you want to enable rate limiting and make sure no one abuses the API. If you're using, for example, some packages as part of like an API endpoint function, right? Part of your logic actually uses marked, so you want to make sure that your code is secure, but the dependencies you're using are also secure. And when you build this application and maybe you push it into like the cloud, you like containerize it or something, you want to make sure the container is built in a correct way. So or like a lot of those like best practices that you should probably be following. So that's why this is like really, really great question. There's no one thing that you should do. You should do a lot of things to make sure that this is, this is kind of like working, in a safe way, like very, kind of like following the correct best practices to do it. I would say there's a bunch of stuff. If you just go, for example, to, I think we have it on Learn Sneak.io. Just want to learn a little bit about some about like JavaScript security. If you're asking about Node.js, or like server-side request forgery, what that is, why that is important, and you just like learn a little bit here. It's a kind of like a very interactive session. By the way, all of the stuff that I showed you, like all the Sneak stuff, all of this, none of this is really like all of this is free. You don't have to pay for anything. This is like you don't even need an account to like learn from here. This is fully interactive, right? Like we can start learning about what server-side request forgery is. So definitely skill up, learn about a lot of those things. I'll be sharing after this on Twitter a bunch of best practices in terms of NPM security, container, etc. So you can find me on Twitter or just go to the Sneak website. And if you go to the blog, there's some resources here. Over we have changed a lot of things, but I think it's where is it? Developer and security resources. So there's like a bunch of stuff on the blog, but also if you just go here to like this section, it gives you like cheat sheets on a lot of things, like how to React security practices, Angular, how to containerize Node.js web applications, and these really do deep, beyond the the cheat sheets, like the PDF thing that you should like have as a nice handy tool. We go through like all of the stuff, like how to build a correct container for Node.js, like what you should actually follow, why you should do it. So it's like a very step-by-step thing. A very long answer, but this is also a very important and big question. Hope it helps.
Well, very true. So I guess we have one more question. So even I'm curious about this one. So before we get started, like, is it okay if I ask you, do you have the time to spare? Because we are already past the time.
Yeah.
Okay.
No worries. Like we have it. Okay, I have a few more minutes here.
Okay.
The Sneak push. What is it? The Sneak push our app vulnerability to their clouds.
I guess what it's trying to ask is like basically when Sneak is evaluating the app, the Node.js application, like does it push the application with the vulnerabilities to your cloud, and does it like make your cloud vulnerable? I think.
Oh, see, no, it doesn't. So okay, this is a really great, insightful question, because it's like, how does the thing work? So let me run through this again. So Sneak depends what we do, but like the product, the Sneak product thing does a bunch of things. And if we go back here, so you can use Sneak for all like in different ways. So you could just do. Let me open another window here. So you could do npm install Windows GH Sneak and just get the Sneak CLI. Once you have it, you need to like do a quick Sneak auth and you authenticate like with a browser, get an API token, and that's it. That the moment you do that, you have the CLI for you, and it supports like all of those things. Like Sneak test will run, will look at the package JSON and the package lock files that you have. So when we do a Sneak test and we test your open source dependency, like this output, what we do here, we simply send to like the Sneak like backend thing, basically your package manifest. That's it, and just the dependencies there. We at this point, like, we don't care about like your code, or we don't try to deploy it. We don't store anything. If you do a Sneak code test, which looks at your code, so it actually needs to go through all of my source code, analyze it, and then give you input. I don't know if I have it enabled. Let's see if it works. But if I do this, essentially, yes, like you see, this is like taking a little bit more longer, just because we're like zipping and uploading the code base and sending it there. We don't ever store it like as is. We can like do it in a secure way. We can like hash it, and then it expires and doesn't exist anymore. And we just use it for analyzing like how things happen. So you see all the SQL injection, command injection, it's all here, and you get that. So we don't deploy anything. You can do the same thing with container tests, because I essentially have here a Docker file. So my containerized application may have issues in it, and you could do the same thing. By the way, this is already integrated into Docker. If you do Docker scan, you get the same output of like container vulnerabilities. But yeah, this is a good question on like how things work. We don't deploy anything. We just look at either your code, your package manifest, depending what you want to test. The simplest way to get started, also what I suggest if you want to do, if you want to join like the big fix event, is essentially just to here, like once you like going to like app.sneak.io and like create an account quickly with GitHub, just do this, add project, GitHub or GitLab, wherever you store your projects. And just, when you add them, we will scan them and you get those I would say like report project status back, so that you can start fixing things here and figuring out what you're vulnerable to.
Yeah. So I did that. It did answer my question, and I guess it answered someone's question as well. So
Cool.
we'll be sure to visit this site maybe like tonight as well. So I guess we have more questions coming, but I don't think we have the time. So maybe like we could arrange another session with you in the near future, if that
I love it.
possible.
Yeah,
Great.
let's do it. I have to jump indeed somewhere
Yeah.
else, but thank you everyone. Thank you, Akalanka, for this session. Let's just schedule another one. I think we can. This would be really cool, and we can like learn maybe new things on different sessions. That would be nice.
Yeah, that would be nice for everyone as well. So
Okay,
once
love
again,
it.
thank you for joining with us today, and especially for accepting our invitation. And I guess
Thank you for
that the
having
knowledge
me.
that you transferred to us today, it will be like really helpful in the long run, and it will be really helpful for me especially. And I guess with that we can conclude. And for those for you who are watching, just keep in touch with us as we'll be bringing to you more live streams like this. So I guess that's it for today then.
Sounds good. Bye everyone. Thank you.
Bye.